Our topic today is about probability. In this session, we will be discussing how to analyze a statistical table. We will begin with a general view. Then we will learn how to analyze events, study of intersection, study of union, complement of an event, incompatible events, conditional probability, and we will end up with a supplementary exercise and its solution. Number 1, general view. In what follows, we will be discussing how to calculate probability using statistical tables. Let's consider the following statistical table. I need you to know that the first step, even before reading the questions, we should write the total of each column and each row. So, step number 1. We have to write the total of all columns and rows. First, here A, we have 9 and 21, 30. 6 and 19, 25 for B. C, we have 9 and 6, 15. 21 and 19, 40. The sum of 15 and 40 and 30 and 25, these should give us the same sum. They have 55. Now, you should know that each of the rows and columns, here we have this column which is titled by A. This represents an event A. Similarly for B, and similarly to the rows C and D, as you can see here. How to analyze events. We will now discuss the probability of each event. First, let's begin with event A. If you look here at A, we have 30 elements in A. This is the sum of the event A. Therefore, to find the probability of A, we look at the total of the column A, which is 30, and then we divide it over the total which is under study here. In this case, it is 55. Therefore, P of A is equal to 30, which is the cardinal of A, over the total, which is 55, which is equal to 6 over 11. Probability of B, similarly, we have in the column B, we have 25. Therefore, the probability of B is the total of B, which is 25 over 55. Similarly, probability of C, of event C, is equal to 15, which is the cardinal of C, over 55. And at last, we have probability of D is equal, if you look here at D, we have 40 over 55, which is equal to 8 over 11. Number 3, study of intersection. Let us analyze the intersection of the two events A and D. Here I need you to know some of the terminologies about probability. Whenever you have event A and D, this and means intersection. So A and D means the intersection of the two events A and D. So this and is very important in the terminologies of probability. And you know for sure that the notation of intersection, we write it this way. So it is like A intersection D. Let's observe the adjacent figure. In all this session, we will go through the same example and we will study it. So here we are going to find the probability of A intersection D. This is A. You put a circle around all the numbers in the column A. Intersection D. This is D. So, where is the common part between A and D? Here is the common number between A and D. Therefore, the probability of A intersection D, we take this number, which is 21. So it is equal to 21 over the total, which is equal to 55. Now let's have a practice about the intersection of events. Calculate the following probabilities. First, we have probability of A intersection C. Observe, this is A, event A, and intersection C. So C and A, they intersect here at 9. Therefore, the probability of A intersection C is equal to 9 over the total, which is 55. Now the probability of B intersection C. This is B and this is C. They intersect here at 6. So therefore, the probability of B intersection C is equal to 6 over 55. Probability of B intersection D. In the same way, this is B and this is D. They intersect here at 19. Therefore, the probability of B intersection D is equal to 19 over 55. Keep in mind the probability of B intersection D and D intersection B is the same. Now let's go through the probability of A intersection B. Here I need you to focus. This is A and this is B. A intersection B. Here we have no intersection between A and B. Therefore, the probability of A intersection B is equal to 0 because we have no intersection. So if A intersection B, which is in this case it is phi, then P of A intersection B is equal to 0. Similarly for C and D, nothing is common between C and D, therefore the probability of C intersection D is equal to 0 as well. Number 4, study of union. The union of two events, A and D, which we call it event A or D, is selecting all elements in A and D. So here, another note regarding the terminologies of probability. Whenever we have A or D, this or means union. The notation of the union is this, and A union D, we write it in this way. Observe the adjacent panel. We have the same table here. We need to study the probability of A or D, or in other words we say A union D. We have A union D. These are the elements of A and these are the elements of D. We count all the elements in A and D. So It's like saying we have 9 plus 21 plus 19, so we got 49. Therefore, A union D contains 49 elements. Some students might ask, can we just add the total of A and the total of D? This is wrong. Look at the total of A, 30. The total of D is 40. Then the sum of these will give us 70. But the real answer is 49. So don't be confused with this. So the probability of A union D is equal to 49 over the total, which is 55. Let's have a practice here about union. We need to calculate the following probabilities. Probability of A union C. This is A and this is C. We have 6 and 9. 6 and 9, 15. 15 and 21 gives us 36. Therefore, probability of A union C is equal to 36 over 55. Probability of B union C. This is B and this is C. Therefore, we have here all 15 and 19. This gives us 34. Therefore, the probability of B union C is equal to 34 over 55. Probability of B union D. This is B. We have 25 union D, so 25 and 21. We have 46. Therefore, the probability of B union D is equal to 46 over 55. Now look here at the probability of A union B. This is A and this is B. The union of these two events is equal to the total, which is equal to 55. We call A union B a certain event because its total is equal to the total number under study. Therefore, the probability of A union B is equal to 1. And similarly, the probability of C union D gives us 1. I will go back to this example, which is the probability of A union C. We have the event A and this is the event C. So the probability of A union C, this is one of the properties of probabilities, is equal to the probability of A plus probability of C minus the probability of A intersection C, which is equal. Let's solve this. Probability of A is 30 out of 55. So we will write here 30 over 55 plus probability of C, which is 15 over 55 minus the probability of the intersection between A and C, which is 9 over 55. If you calculate this, you will get 30 plus 15 is equal to 45 minus 9, we will get 36, which is the same answer we get above.
Number 5. Complement of an event. The complement of an event A with respect to the universe S is the subset of all elements of S that are not in A. We denote the complement of A by the symbol A bar. English-wise, it's somehow difficult to understand, but let me go through further explanation. We have 30 elements in the event A. The universe under study here contains 55 elements, so I will write here universe S. Universe means all elements under study.
we have 55 elements. Which elements that completes A to form the universe? They are the elements of B. So here, these 25 elements here are the elements in S that are not in A. So we say that B completes A, or B is the complement of A. Therefore, A bar is equal to B. We say A bar is the complement or opposite of A. Let's find now the probability of A bar. This is very simple now. P of A bar is equal to P of B, since A bar is B, is equal to 25 over 55, which is equal to 5 over 11. We will have now some practice about this. Let's begin with the probability of B bar. Here this is B. Therefore, A is equal to B bar. What completes B is A to form the universe. So, the probability of B bar is equal to the probability of A. Therefore, probability of B bar equals 30 over 55, which gives us 6 over 11. Probability of C bar. This is C. Therefore, C bar, what completes the event C to complete the universe, is the event D. Therefore, the probability of C bar is equal to the probability of D, which is 40 over 55. So here we have 40 over 55, which is equal to 8 over 11. Similarly, probability of D bar is equal to the probability of C, which is equal to 15 over 55. So here we have 15 over 55, which is equal to 3 over 11. Now we will find the probability of B bar union C bar. Let's erase here. Okay. So, probability of B bar. B bar is A. So here we are focusing on A. This is B bar. And C bar is D. Therefore, this is C bar. We need to find the probability of B bar union C bar. So we count all the elements here, which are 9 and 21, 30, and 19, 49. 49 out of 55. Therefore, here we write 49 over 55. Now we need to find the probability of B intersection C all bar. First, we find B intersection C. In these exercises, we move gradually, actually, step by step. First, we find B intersection C, then we find the bar of B intersection C. So let's begin. B intersection C, this is B, and this is C. These two events intersect at 6. So, what's the complement of this 6? Are all the other numbers found? 21 and 19, 40, 49, therefore, is equal to 49 over 55. Now let's move on to find the probability of B union C all bar. So, also step by step. First, we try to find B union C. This is B, and this is C. So the union of these are all the elements found here. If we look here, we have 9 and 6, 15, 15 and 19, 34. What's the bar of this? It's the 21 here. Therefore, the answer is 21 over 55. So here we have 21 over 55. Now, probability of B bar intersection C bar. We said before that A is B bar. So this is B bar. And D is C bar. So this is C bar. They intersect at 21. So the probability of B bar intersection C bar is equal to 21 over 55. Now we have to find the probability of A union B all bar. Look here, this is somehow tricky, but it's very important. A union B. First we go through A union B. This is A and this is B. Their union. Here, if you look here, A union B is equal to the universe S. What completes the universe? To attain the universe, it's nothing, because the universe is completed here. So what we are trying to say, if A union B is equal to S, then A union B bar is equal to phi. So the probability of phi is equal to 0. Therefore, here we have a 0. Let's move on to the last point, which is the probability of A intersection B all bar. First, we find the probability of A intersection B. If we look here, this is A and this is B. You know, here A intersection B is equal to phi. What completes this to attain the universe? It's the universe by itself. So if A intersection B is phi, then A intersection B bar is equal to the universe S. And what's the probability of S? For sure it is 1. There is a special reminder. If you look here at these exercises or these equations that we have just solved, calculations, sorry. Look here, P of B bar union C bar and P of B intersection C all bar, they are equal. Therefore, this reminds us of De Morgan's rule. This is De Morgan's rule. Which states that, this is very important, it states that the probability of B intersection C all bar is equal to the probability of B bar union C bar. Also, have a look at this. If we have the probability of B union C all bar, it's equal to the probability of B bar intersection C bar. So another point, we say probability of B union C all bar is equal to the probability of B bar intersection C bar. So if we separate the bars, here we have to reverse the sign. Incompatible events. Two events A and B are said to be incompatible or mutually exclusive or disjoint if A intersection B is equal to phi. Here you have to know that these three words are the same, so you might pass by any of these, but you should know that incompatible or mutually exclusive or disjoint, they are the same. Let's observe the following table. Here, if we can look at the two events A and B. The intersection of A and B, we have no intersection between A and B. So we say that the event A intersection B is equal to phi. If we have to go through a more illustration, I will try to explain this using a Venn diagram. Whenever here in a Venn diagram we have two events, let's say this is A and this is event B. Look here, there's no intersection between the two circles, therefore A and B are mutually exclusive or incompatible. Also, if we look at the table, we can also notice that C and D are incompatible since there's no intersection between C and D. So for incompatible events, the intersection, the first thing we should keep in mind is that first, if A and B are incompatible, this means that the probability of A intersection B is equal to 0. Since there's no intersection, the intersection is equal to phi. Also, we have seen this before, probability of A intersection B all bar will be equal to 1 because we will be talking about the universe, which completes this phi in order to attain the whole elements under study. One more thing which we will need to discuss. We have seen before that probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B. If A and B are incompatible, look here, then this is equal to 0. So therefore, one of the ways also to prove that two events A and B are incompatible is proving that P of A union B is only equal to P of A plus P of B. P of A union B is equal to P of A plus P of B. This is only valid if A and B are incompatible. Number 7, conditional probability. This is one of the most important topics we will be discussing. The probability of an event B occurring when it's known that some event A has occurred is called a conditional probability. And we denote this probability by P of B slash A. In conditional probability, you have to know that the occurrence of two events is relative. So, for example, we say if A occurs, then what's the probability that B occurs? So, there's a relativity between two events. The main formula of conditional probability is P of B slash A is equal to P of B intersection A over P of A. Here, in conditional probability, for example, we say given that or knowing that A occurs, what's the probability that B occurs? Therefore, this A, if we say P of B slash A, then in other words, we are saying given that A occurs, or knowing that, given that A, or knowing that A occurs, knowing that. So, the event which is under the slash here stands for the giving that or knowing that A. One more thing to talk about here. Out of this rule, actually we know we can get another formula. It's that P of B intersection A is equal to P of B slash A times P of A. So here we will write P of B intersection A is equal to P of A times P of, sorry, this is times P of B slash A. Or we can say also another thing, that P of B intersection A is equal to P of B times P of A slash B. Now let us try to explain the conditional probability using this example. But first also I need you to know as well that if B and A are incompatible, then probability of B slash A, or the conditional probability, will be equal to 0. So here, if incompatible, then P of B slash A will be equal to 0, since P of B intersection A will be equal to 0. Now let's explain this. P of B slash C. P of B slash C. Here I need a lot of focus, because there's a certain way actually we use in tables in order to find the conditional probabilities. The first thing is, as we have said, this means that knowing that C occurs. Knowing that C occurs, this indicates that we are working just on C occurs. So I need to highlight this. Then you have to forget anything other than C. This is C. So I'm highlighting this because knowing that C, we will just work on the event C. Anything other than this shaded region will be neglected. We need to find the probability of B knowing that C. Look here. This is the event B. We are talking about this region. So knowing that B, or knowing that C, sorry, what's the probability of B? Then we are B here, we have 6, because this is the intersection. So this, out of what are we taking this 6? Out of the total of 15, because we are neglecting all the others. Therefore, the probability of B knowing that C is equal to 6 over 15, which we get 2 over 5. Let us solve it by the formula. We know that P of B slash C is equal to P of B intersection C over P of C. B intersection C, here this is C and this is B, they intersect at 6, so it is 6 over 55. So we will write down 6 over 55 over P of C, which is equal to 15. C, we have 15 over 45, so over 15 over 45. If we cancel this by this, we get 6 over 15, which is equal to 2 over 5. But I will repeat also the first method because it's simpler to find it using the table. So first thing, we color the C because we are working the C. What's the probability of B here now? It is, if we look here, then B slash C, we are talking about this B because we neglect all the others. Therefore, it's 6 out of the total, which is 15 in this case. So here, 6 over 15. Let's move to P of A slash D. So, P of A slash D, then we are
working on D. So the first step, we need to shade the D. We are just working on D, so we shade the D. We are saying P of A slash, this is event A. We said that we have to neglect anything other than the shaded part. So P of A slash D is equal to 21, which is related to the A here, out of 40. So we will get 21 over 40. Now let's move to find P of C slash D. Look here. We already know that C and D, they are incompatible events. So C and D are incompatible events, meaning their intersection is equal to phi. If two events are incompatible, then the conditional probability related to them is equal to 0. So here we will write P of C slash D is equal to 0, and P of A slash B is the same, equal to 0, since A and B are incompatible. Now we will be solving together this supplementary exercise. In this exercise we have 60 students of a language class which have the choice to learn Arabic, English or French. Each student chooses only one language. The students are distributed as per the following table. Here in the columns we have those who study Arabic, English and French, and here we have girls and boys. Here I made it easier for you, so I added the total. We have two given. We are choosing a student randomly, and we have two given events. E, which stands for those who the chosen student studies English, and B stands for the chosen student is a boy. I copy the given to the next page here. So here we have the table and the events. In number 1 we have to calculate the following probabilities. Probability of E, those who study English. So we take the total number or the cardinal of E, which is 18, over 60, which is the total number of students under study. So it's 18 over 60 is equal to 3 over 10. Probability of B, similarly here this is the event B. We have 35 boys, therefore it's 35 out of 60 is equal to 7 over 12. Probability of E intersection B, this is the English event, this is E, and so I will put here E and B for boys, and here is the event B. These two intersect here at 10, therefore E intersection B is equal to 10 out of 60, which is equal to 1 over 6. Probability of E union B. To find E union B, we should count everything included within E and B. So here, if we count 9 plus 10, 19 and 16, 35, 35 and 8, so we get 43. We take all the elements which are in E and B, which is equal 43 out of 60. Here I wrote it in a different way, because I need you to get used to the other way, which to the equation which says that P of E union B equal P of A plus P of B minus the intersection. If you look here, the boys we have 35, so it's 35. The girls, the English event is 18, so we add 35 plus 18, which will give us 53, and we subtract the intersection, which is 10. So here I wrote 18 plus 35 minus 10 over 60. We got the same answer, which is 43 over 60. Now, in number 2, the chosen student is a boy. What's the probability that he is studying Arabic? Look at here. There's an affirmation that the chosen student is a boy. Therefore, we are dealing here with conditional
probability. These two events, Arabic and boy, they are relative, so this is conditional probability. It's the same as saying knowing that the chosen student is a boy or given that the student is a boy. These are all terms that indicates that it is a conditional probability. So given that, we said before that given that should be under the slash. So slash b, because given that boy, given that b, therefore it is under the slash. So we are finding p of Arabic slash b. The first thing, as I told you before, we have to highlight the boys. So here I'm highlighting the row which stands for the boys, and we neglect anything other understudy. This stands for Arabic. So here we just take the intersection between studying Arabic and the boys. Therefore it's 9 out of, if you look here 9, the intersection of Arabic with the boys, out of 35. So P of boys intersect, which is 9 over 35, as you can see here. Now moving on to question number 3. Two students are chosen successively. What is the number of all possible outcomes? This is counting. First I will jot down a certain note. Whenever you have successively or one after the other, this indicates that order should be taken into consideration. So here we have order. Order should be respected here. We are choosing 2 students. So in front of us there are 60 students and we have to choose 2 students from them. If we are choosing out of 60, then we have 60 options to choose the first student. Now we have to select the other student. For sure, if we have 60 students and we chose the first student, then for the second student we will have 59 options in front of us. Therefore, the number of all possible outcomes will be 60 times 59, so we get 3540 outcomes. In 3 part B, we have to calculate the probability that the 2 students are a boy and a girl. We are selecting 2 students, boy and a girl. The first selected student might be a boy and the second a girl, or the first might be a girl and the second might be a boy. Here, if we look here, we have how many options for the boys? I will try to solve it in 2 different ways. For the boys we have 35 boys, so the first is 35 boys out of 60 times, we are looking here at the girls, we have 25 girls, therefore 25, but this 25 is out of 59 because the remaining are 59. So this is the first, or the first one as a girl, so it is 25 over 60 times, or means a plus, sorry, times the second for boys, 30 boys over 59 out of 59, so we will get the answer. Or in other ways, we can simply write 35 over 60, which is for the boys here, times 25 over 59 times 2, because we can reverse them. We can take the boy first and then the girl, or the girl first and then the boy. So we will get the answer. This brings us to the end of our video. Hope it was productive for everybody. Thank you.